Come on. Okay, and here's part 2. All right, there we go. So I'm going to go north 35 degrees. So I take my, now I can think of this more as a protractor, and rotate 35 degrees. 10, 20, 30, 35 degrees is right about there. So I'm going to mark my path. Nope. I got distracted. Nope. What am I doing wrong? I'm going to the west, not to the east. Thanks, Spencer. Nope. This is wrong. I'm going the wrong direction. I'm not going to wind up. I'm going to wind up in the wrong port. I'm going to get stopped at customs. Better go the other direction, right? So I'm really going this direction, 35 degrees. .35 okay? So, or we could say it's 0.35 degrees, the same thing, okay? Now, draw a vector diagram south 20 west, all right? Let's see if I can do that, okay? Compass rose. North, east, south, west. South, I'm going to point south, right? I'm going to go 20 degrees towards the west. Okay, does that make sense? Here, I'll see if I can show you. 20 degrees towards the west. See, looking south, I'm going to go 20 degrees towards the west. Okay? Alright, so I'm just going to find my protractor and measure 20 degrees. Right about there. Draw that in. Okay. Or we could call this 180 plus 20, or we can call it a bearing of 200 degrees. Okay, both are the same thing. Okay, because I got my 180 degrees from north to south plus 20. Okay, so okay, now that we know how to do that, let's take a journey. You guys ready to take a journey? Let's turn the page. Let's take a journey. Don't you wish we could really do this? Wouldn't that be fun? Okay, so 2 ships leave port at the same time. Ship A, should say A with a capital A, but ship A, let's make that an A, travels 12 knots at a bearing of north 55 east. So he's kind of going this direction. Okay, he's kind of going this direction. Ship B travels 8 knots at a bearing of south 10 west. Okay, so it's kind of going this direction. Okay. Okay. Draw a scale drawing. Alright, let's see if I can do that. Let's put port. I'm going to put port right about here because I kind of know which way they're going. There's my port. That's where they start. Let me put my compass rose down. Ship A is going to travel north 55 degrees east. 55. Okay. And I'll slow down in a second. Okay. Ship A. And what I'm going to do, since they're going 12 knots, I'm just going to use a ruler. I'm going to draw in a length of 12, okay? So I'm just going to go, since it's 12 knots, I'm just going to use 12 centimeters. Okay, so my length, I'm just going to use 12 centimeters, which is way up here. Okay. So there's ship A after 1 hour. Ship A is way up there after 1 hour. Okay, so just use my ruler and measured it 12. Okay. So I've got 55 degrees here. Am I going too fast? How am I doing? Am I doing okay, Zoe? Am I doing okay? I'm not going too fast? Okay. Okay, ship B is going south 10 degrees. So I'm using my protractor. So I'm pointing south. And we'll go 10 degrees. Okay, 10 degrees towards the west, right? We're going towards the west. Okay. And 8 knots. So I'm going to just draw this 8 centimeters. I'll call it 8 knots. Okay, so I'm all the way down here. Okay. Kind of going off my page for this. Okay. I could have I could have scaled it down by half. I could have. I didn't think of that, but that's all right. So this is 10 degrees here, and this is going to be 8. All right? All right, let's see. I want to find out how far apart they are. I'm going to draw that in, okay? This is going to be my 12. Let's see, 55 and 90. I want a couple of things. 55, let's see, 90 minus 55, 35, right? This angle's 35. Do you guys agree with that? 35 degrees from north. I need this angle. This angle's 90 between east and south, okay? So if they go for 3 hours, the triangle gets bigger but doesn't change shape. I'll say it again. If they go for 3 hours, the triangle gets bigger but doesn't change shape. So I don't want to draw the triangle bigger. You okay with that? I'm just going to scale it, right? So I'll say, okay, let's multiply this by 3. So this length is now 36. Multiply this by 3, so this length is 24, okay? So now they've gone for 3 hours. This one's 36 nautical miles away from port. Ship B is 24 nautical miles away from port, okay? So the question is, how far away are they? Well, if I add this angle, right, I've got my 35, my 90, and my 10. Let's see, that's 135, right? 135 degrees. 35, 90, and that's 100, 135 degrees. 135 degrees, right? And what I have is side, angle, side, right? And then yesterday we talked about if we have side, angle, side, that we can use the law of cosines. Remember that? So I can find this using the law of cosines. Okay, so I'm going to set up my c squared, because that's my opposite squared, equals my adjacent squared, 36 squared, plus my other adjacent squared, 24 squared, minus 2 times my adjacent times my other adjacent times the cosine of my angle, which is 135 degrees, right? How am I doing, okay? And then I'm just going to use my calculator. And I'm going to go, okay, I'm going to go 36 squared plus 24 squared minus 2 times 36 times 24 times the cosine, 135 degrees, right? And then, of course, I'm going to take the square root of that because it's c squared. Plus, they're not this far apart. That'd be crazy, huh? Square root, right? 0.88. Square root. Just get the square root of that answer. So I get about 55.6. And that answer sounds about right. I mean, if they're 24 here and 36 there, then 55.6, uh-oh, getting dyslexic again, could be okay, right? Now,
what is it? 55.61.
oh, great question, nautical miles. So it's like miles per hour, but a knot. Were you here when I talked about what a knot was?
No.
Okay, so you ready? Knot's easy. You know how the Earth is divided up into parallels, longitude, latitude, parallels, and every degree is something like maybe a couple hundred miles, right? So if you take a degree, divide that by 60ths, you get a minute, which is, I don't know how many miles, and then you divide that by 60, and I think it's about a couple of miles is 1 nautical mile. Okay, so it's a length. And of course, in this case, it is a length. Sometimes it can also be a speed, right? Like miles per hour, but instead it's like nautical miles. Okay, now, if ship B, so ship B is way down here, if it gets disabled, what bearing must ship A take to rescue ship B? Okay, so let's see. Let's do this one. So ship A is sitting way up here. Ship B drops anchor, and ship A has to come around and rescue. So he's going to have to look at his compass. So way up here, he's going to make his compass rose. Okay. And ship A is going to have to basically turn the boat all the way around to that bearing. Does that make sense? Okay, now, there's a few things I probably know. Okay? And I don't know if you guys remember this from geometry or not, but these two lines are parallel, obviously, but this Z pattern here, we learned in geometry, is alternate interior angles. Okay, who cares, right? You don't remember that. But then if this angle's 55, this angle's 55. You agree with that? Okay, good. All right, I'm making some sense, aren't I? So this angle here, the whole angle is 55 degrees. If I can find this angle A, call it theta. If I can find this angle, I can subtract it from 55, and I'll know this angle. Okay, does that make sense? Okay, so if the whole thing's 55, I want this angle, subtract it from it, and then I'll get this angle. So let's find this angle here. I have opposites. So let's set up the lost signs to find theta. So we go sine of theta over 24 equals the sine of 135 over 55.6. Okay, now it'll give me theta. Okay, let me scoot it up. Okay, so I do my opposite. I'm going to do the sine of theta over 24 equals the sine of 135 over 55.6. Okay, multiply up to 24, right? And I'll use my calculator. Okay, I'm going to go 55. I'm going to go 24 times the sine of 135, close your parentheses, divided by 55.6. Now I get a decimal. I expected that. Now I do the sine inverse of that answer. And so I get an answer of 17.8. We'll just say 17.8. Okay, so now let me go back to my drawing. So, you ready? Let me see another color, okay? So this angle here is 17.8. The whole angle is 55. Let me subtract the two angles. Let me go then my 55 degrees. That's the whole thing, right? Minus my 17.8 degrees. I get a 37. So that means this angle here, okay, is 37.2 degrees. So, what's my bearing? We're going to go south, right? We're going to go south. 37.8 degrees towards the west. How's that? Pretty cool. We're actually doing math that can actually be applied. I love it. Life's good. All right. I'll load up this video. I'll have to load up both.